Helicopter Flying Handbook 3.1 Helicopter Flight Controls. In the delicate ballet of helicopter flight, the pilot wields three primary controls: the collective pitch control, cyclic pitch control, and antitorque pedals. Alongside these, the throttle control plays a pivotal role, typically co-located with the collective pitch control, guiding the helicopter through the symphony of aerial maneuvers. Irrespective of the helicopter's main rotor configuration, the control systems discussed herein find application across diverse helicopter designs. Notably, for counterclockwise main rotor blade rotations, the standard frame of reference is maintained throughout this discussion. The collective pitch control, a luminary among the controls, rests on the left side of the pilot's seat. Operated with the left hand, this control orchestrates changes in the pitch angle of all main rotor blades concurrently, a collective, harmonious movement. Its elevation increases pitch angle, inducing a uniform rise in all blade angles, and conversely, lowering the collective pitch control decreases pitch angle collectively. A nuanced ballet unfolds as the pilot navigates the mechanical intricacies, adjusting the collective pitch to guide the helicopter through the aerial performance. A captivating subplot introduces an adjustable friction control, a subtle force that safeguards against inadvertent collective pitch movements, ensuring a controlled performance. The throttle control, entwined in this aerial sequence, regulates engine RPM. A twist grip throttle, often adjacent to the collective pitch control, offers a tactile interface for the pilot. Rotating it counterclockwise elevates engine RPM, while a clockwise turn diminishes it, allowing the pilot to modulate power seamlessly. Governors and correlators step into the spotlight, enhancing the performance. Governors, prevalent in turbine helicopters, sense rotor and engine RPM, maintaining a constant rotor RPM effortlessly. Correlators establish a mechanical bridge between the collective lever and engine throttle, dynamically adjusting power as the collective moves. Together, they contribute to the fluidity of the performance. In this aerial sonnet, the delicate balance of control extends beyond collective and throttle coordination. For piston helicopters, where manifold pressure and RPM share the stage, each control assumes a dual role: collective pitch influencing RPM and the throttle impacting manifold pressure. The tachometer and manifold pressure gauge become the maestro's score, guiding the pilot through the symphony of control inputs. In the dynamic ballet of helicopter flight, the pilot orchestrates movements through three primary controls: the collective pitch control, cyclic pitch control, and antitorque pedals. The collective, located on the left side, modulates the pitch angle of all rotor blades collectively, impacting lift and enabling ascents or descents. The cyclic, often protruding between the pilot's legs or seats, serves as the maestro of directional flight. Tilting the rotor disc in the desired direction, the cyclic allows the helicopter to gracefully navigate forward, backward, left, or right. The mechanical finesse of the cyclic lever is calibrated to harmoniously adjust pitch angles, ensuring controlled and precise movements. Antitorque pedals, gracefully placed on the cabin floor, are the controllers countering the rotational force exerted by the main rotor. These pedals control the pitch of the tail rotor blades, crucial for maintaining heading and counteracting torque-induced rotations. Their movements are a delicate choreography, allowing the helicopter to turn 360 degrees during a hover and maintaining longitudinal trim during forward flight. Heading control, an essential element of the performance, relies on the tail rotor's thrust modulation through the antitorque pedals. By adjusting the pitch angle, the pilot steers the helicopter, executing graceful turns and maintaining a balanced heading. Vertical fins or stabilizers contribute to this maneuver, optimizing directional stability. As the pilot commands the collective, cyclic, and antitorque pedals, they seamlessly blend inputs, adapting to the aerodynamic nuances of flight. The delicate balance between control inputs and aerodynamics creates the symphony of controlled flight, a collaboration between the pilot and the machine. In the intricate world of helicopter controls, each movement is a note, and each adjustment a step, contributing to the fluidity of flight. This chapter serves as a guide, introducing pilots to the major flight controls and unraveling the synergy between these controls and the principles of aerodynamics.